So as promised, we're going to talk about variables. And initially, we're going to break them into two groups, categorical variables and quantitative. I said last time, quantitative are numbers, and categorical are just categories. And sometimes the categories are coded by numbers, like your zip code or something like that would still be considered categorical. For something to be considered quantitative, more or less, there should be units attached. So usually things like degrees Fahrenheit or pounds or feet, things like that. And then over here in the categorical side, it could be nominal. As you might think, nominal means names. And ordinal means categories with some kind of order. So what do you mean? How could you have categories and have order? Well, you could say, well, what kind of day do you expect it to be? You're going to say, I think it's going to be cold. Or I think it's going to be warm. Or I think it's going to be hot. I think it might be windy. I think it might be calm. Those categories have order. That windy somehow has more movement than calm, and cold, warm, and hot. They have an order. So those are ordinal categorical variables. Otherwise, just like names, what city do you live in, what language do you speak, what's your ethnicity, those are names with no implied order. Okay, and over in quantitative, the quantitative ones could be interval, where that means interval more or less means it makes sense to compare them and add and subtract them. So what kinds of things could you compare by adding and subtracting? Maybe degrees Fahrenheit. There's hotter and colder days, 5 degrees warmer than last time and 10 degrees colder than last time. You can compare those differences. And otherwise, quantitative variables are often ratio, where you can talk about ratios. Twice as much of something is a ratio, half as much of something is a ratio. So you're talking about how tall someone is. Someone can be half as tall as someone else. The ratio makes sense because 0 represents no height. So for ratio quantitative variables, typically 0 has meaning none. And for interval quantitative variables, 0 is just an arbitrary number, like in the Celsius scale, 0 is the freezing point of water. In the Fahrenheit scale, 0 is just a cold temperature. Somehow people figured out that's pretty cold, so we're going to call it 0 degrees. It doesn't have any intrinsic meaning. So when that happens, we say we have an interval variable. When 0 has some kind of meaning that we'd agree on, that 0 means nothing. There is a 0 in the temperature scale, 0 degrees Kelvin, but that's so far away from our ordinary existence that we ordinarily don't refer to that when we talk about how hot it is outside or how cold it is. It's not something that we think about having 0 of, because that's so amazingly cold that nothing can even live like that, and it's even colder than the Earth is ever, any place on Earth, and things like that. On top of that, the quantitative variables can be discrete or continuous, either one, discrete or continuous in either case. And discrete means there's only a certain number, a finite number or a countable number of values you're allowed to see. So when you're measuring something, not very accurately, like how many acres is the property, you say 1 or 2 acres, something like that, that would be considered a discrete variable. But if you measured it accurately, 1.073 acres, you would consider that now continuous, because you could just basically get any kind of number. So the idea is discrete, only a finite or countable set of values. Continuous values are from an interval of the real line. You can see by what I was saying there that sometimes something that's continuous becomes discrete because we more or less round it. So you ask somebody, how old are you? They're going to say, 20 years old. They're not going to say, I'm 19.876 years old. So we'd consider that a discrete variable, even though it's really a continuous quantity. So some things are just basically discrete, like how many eggs broke when you dropped the carton. It's a certain number of eggs. There's nothing you can do about it. How many credit hours have you signed up for so far or passed so far? It's a solid number. I don't think we have any possible value for credit hours. Maybe there's half credit hour classes, I'm not sure. How many cars have you owned in your life? How many brothers and sisters do you have? How big is your immediate family? All those kinds of numbers are discrete. The ratio, because 0 makes sense, there's none. None, no people in your immediate family, that's kind of hard to do. You could have not passed any classes so far. You could have not signed up for anything. No credit hours completed so far. And so it could be a ratio or interval. What other kinds of discrete variables are out there? I suppose if you are asked somebody how much money is in your pocket, that's certainly discrete. It's just not going to be any possible value, maybe down to the penny, but there's just a finite or countable number of values makes it discrete. Now, ordinarily, even if you're measuring something that's continuous, the measurement comes out to be discrete because you have only a certain number of decimal places you're recording. So somehow we have to think about the variable in more detail. That what about the actual value? Is it something that corresponds to an interval in the real line? Or is it something that could only happen in a finite or countable number set of values? So if you just investigate the variable in its pure form, and you ask, well, if I could measure infinitely accurately, are there only a finite number of possible values? Like spinning the roulette wheel, it comes to a letter, a number, or a color. I guess the number is the quantitative part. I think it's 1 through, it's double, 0, and 0, so maybe not really regular numbers. But there's only a countable number of outcomes that are possible in the roulette experiment. And so, and then would those be considered interval or ratio? I don't think either one, actually, because basically you're probably not going to add or subtract them. You're not going to take ratios, so maybe they're actually qualitative because they're categorical, maybe because there's spots on the wheel where you don't want to add them. So things get a little bit murky. Ordinarily, it's pretty clear what's happening. If you're measuring an amount and 0 makes sense, it's ratio. And if you measure accurately and it's not forced to be a certain number of things, like when you count something, it might be continuous. And if the 0 doesn't make sense, it's interval. And if you're not now counting something, doesn't make any sense anymore. But maybe trying to think of a situation, I guess we just have to go for it. So here we go. Here's examples so we can see where they fall. Hours slept last night. Okay. It's hours, so it's a number. You got to think of how you'd answer this. I didn't sleep last night, so 0. Maybe I slept 10 hours last night, so maybe 10. Honestly, though, if you're going to talk about exactly how long you slept, it could be any number, 8.2374 hours, or 8 hours and 2.5 seconds, etc. So in that situation, I'm going to go with hours, quantitative. Does 0 make sense? Yeah, everyone would agree if you don't sleep, that's 0 hours. So that makes a ratio. I slept half as long this night as the previous night. That makes sense. Is it discrete or continuous? I'm thinking continuous. I'm going to go ratio, since 0 makes sense. And I'm going to go continuous, because if you could measure it, you can do better than just say 8 hours. You could do a very accurate measurement. Mother, maiden name. Here's name. Name's going to be categorical. And we have to figure out nominal or ordinal. Nominal says names with no implied order. Ordinal says categories with order implied. Names don't have any order. So you don't say because her name was Susan, she's better than someone whose name was Joan. So we're going to go nominal, nominal. Total income last year. Well, 0 makes sense, so it's quantitative. It's ratio. And then it's pretty close to being considered continuous, because if you measure to the penny, there's so many possible values. Another way to think about continuous is you don't expect to see the same number twice. So if you're asking about total income last year, and you ask several people, would you expect to get exactly the same number if they measure to you're a tax person or something, you're looking at the income. You ever see that number again? The answer is probably no. So that's another way to think about it. It's continuous if there's so many values You don't expect to see the same number twice. Weight of your dog. We keep running the same kind of thinking. Quantitative. 0 makes sense. You measure them on an accurate scale. Continuous. In fact, if you weigh your dog on another day, they're not going to weigh the same that day as last day. You won't see that same weight again. Unless you just pick them up and you go, you know what, you weigh about 25 pounds. Next time you're going to go, you still weigh 25 pounds. If that's what you're doing, then they might consider it discrete. Depends what your vet wants you to say. Average speed on I-25, oh, we got the same stuff again. It's quantitative, it's ratio, it's continuous. August high temperature in Pueblo last year. We got quantitative, this is a number. It's temperature, so it's only interval, because 0 has been decided for us by whoever set the scale. It doesn't represent no temperature. And then probably continuous, if you measured it accurately. You could say that color of your socks. What if you're not wearing socks? Then it's got no color, I suppose. You could say that. There are transparent since I'm not wearing them. Don't ask me. Color of your socks. It's categorical. And there's no order to color, so it's nominal, not ordinal. Okay. Fine. I was trying to think of an example, more examples of categorical ordinal. One example here that might make sense is your class standing. So freshman, sophomore, junior, senior. It's a name. But there's an implied order of that you've completed more credit hours as you move down this list. Freshman, sophomore, junior, senior. So there's an order to it, but it's a name, so it's categorical ordinal. And that brings us, I'm thinking, to the end of my sheets here. I think I've actually covered everything on my notes. So these notes that I'm using, they're the same notes I'm posting to Blackboard, so you can print them off and follow along. Sometimes I do exactly what's on the notes, and sometimes I'll stray a little bit away from that, just in the interest of fitting the stuff on the board, and maybe to emphasize certain aspects, or maybe I think of something that fits in with the grand scheme of things. We're kind of restricted here because there's only this much board to work with, and then so sometimes I have to squeeze stuff in like I just did here. I've got space, I might as well squeeze it in because it's useful. So the format sometimes constricts and sometimes helps display things. So here we go. That is the end of the slides for section 1.1. And I'm going to get ready to work on 1.2 next. But for now, I think I'll just see if I can't get these posted out there on YouTube and get it ready for students to use. And I have to review them because sometimes I'll do things during the presentation that I don't recognize, and they'll be kind of silly. That happens because you're trying not to make any mistakes, but you do anyway, and then I have to redo the whole screen. So I hope that didn't happen here. And if it did happen, I hope I don't notice it, and I just post it. How about that? So have a great day, and I'm done for this section.